When you think of construction, what comes to mind? Probably hard hats, right? Steel beams, giant cranes, the smell of concrete. But what if I told you the biggest revolution in building our world today isn't happening on the ground at all? It's happening from the sky. We're going to see how drones are basically creating a digital blueprint of reality and completely transforming construction from the ground up. So let's get one thing straight right out of the gate. The drones we're talking about here, they are not the toys you fly in the park. Not even close. These are sophisticated, industrial-grade tools that are fundamentally changing one of the oldest and biggest industries on the planet.
And this quote, it absolutely nails it. See, a drone in this world is a flying edge device. Just think of it as a flying super smart computer that gathers data. Its main job isn't just to snap a pretty picture. Its job is to sense, to measure, and to digitize the physical world around us with unbelievable precision.
All right, so how do these flying robots actually work? Well, before you can even think about capturing data, engineers have to make a really crucial first decision, picking the right tool for the job. And it all starts with the hardware.
You know, it really boils down to two main flavors. First, you've got your rotary wing drones. These are the multicopters you probably picture. They are absolute masters of hovering and doing detailed, close-up work. Perfect for inspecting a bridge or a really complex building site. Then, you have the fixed-wing drones. These are the marathon runners. They are built for endurance, for efficiently mapping huge areas like new highways or railways.
And this chart, it lays out the trade-offs perfectly. You can see the rotary wing, in pink, just crushing it in hovering stability and how much it can carry. Perfect for those heavier, high-tech sensors. But then look at the fixed wing in blue. It just dominates when it comes to flight time and how much ground it can cover. It's a classic case of specialization. You can't have it all in one package.
So, you've picked your drone. Now the real science kicks in. This isn't just about taking some nice aerial photos. Nope, this is a meticulous, scientific process of capturing a perfect digital copy of reality, one that's accurate right down to the centimeter.
The secret sauce behind all of this is a technology called photogrammetry. Now, it sounds super complex, but the idea is actually pretty simple. It's the science of taking measurements from photos. Special software takes thousands of overlapping images, finds common points between them, and uses some seriously clever math to build out a precise, measurable 3D model. It's like putting together a hyper-realistic 3D puzzle from thousands of photos.
Now, photogrammetry isn't the only game in town. It has a high-tech cousin called LiDAR. So while photogrammetry is passive, it just uses the light that's already there, LiDAR is active. It shoots out tiny laser pulses and measures how long they take to come back. As you can see, LiDAR's superpower is that it can see through trees and bushes to map the actual ground. But photogrammetry gives you that amazing realistic color and texture. And the most advanced projects, you guessed it, they use both.
In this world, precision is absolutely everything. And it's all measured by something called GSD, or ground sampling distance. All this really means is, in the real world, how big is a single pixel from your drone's camera? A smaller GSD, like 1 centimeter per pixel, means you're capturing insane levels of detail. And that's critical for any kind of precision survey work.
And get this, it's not guesswork. Engineers use GSD calculators just like this one to plan out their missions perfectly. They can plug in their drone model, their camera, and then just adjust the flight altitude until they hit the exact GSD they need for the project. So flying at 100 meters up, that gives them a GSD of about 2.7 centimeters per pixel. Perfect.
But wait, how do you make sure your fancy digital model lines up perfectly with the real world? Well, that's where these come in, ground control points, or GCPs. They're basically just targets on the ground with very precise GPS coordinates. And as you can see, where you put them is everything. You can't just bunch them all up. You got to spread them out, surround the site, and hit the high and low points. They act like giant anchors, locking that digital model onto the Earth with absolute accuracy.
Okay, so we've planned the mission, we've flown the drone, we've captured thousands of high-quality images. Now for the real magic, turning all of that raw data into an intelligent, interactive 3D model of the entire job site. The whole process pretty much breaks down into 3 big steps. First, the software aligns all the photos, figuring out exactly where each picture was taken in 3D space. Second, it generates what's called a dense cloud. This is a model made of millions, sometimes billions of tiny little points, each with a precise coordinate. And finally, it connects all those points together to create a solid 3D mesh, and then wraps the original photo textures over it, kind of like a digital skin. And just like that, the model comes to life.
And the result of all that? It is just astonishingly accurate.
I mean, look at this. This is a real quality control report. See that RMSE value? That stands for root mean square error, 0.034 meters. So what does that mean? It means the final digital model is, on average, accurate to within about 3.5 centimeters of the real world. That's not a picture, that's an engineering-grade digital twin.
So this is where it all pays off. We have this super accurate, incredibly detailed digital twin of our job site. So what? Why does it matter? Well, this is where we see how this living model completely revolutionizes the way we build. Well, everything.
We're talking about a massive shift in thinking here. For centuries, construction has run on 2D paper blueprints. Now, it's starting to run on a dynamic, 3D digital model that everyone can share. And the goal is no longer just about finding mistakes after they're already built into concrete and steel. It's about using the data to prevent those mistakes from ever even happening.
Take earth moving, for example. In the past, figuring out how much dirt you needed to move, the cut and fill, was this slow, painful, manual process. Now, you fly a drone for an hour, you upload the data, and the software compares the current ground with the final design. Within minutes, it calculates the exact volumes. That saves a ridiculous amount of time, fuel, and money.
But what about the areas the drone can't see from the air, like under a bridge or inside a building? No problem. This is where data fusion comes in. What you're seeing here is data from an aerial drone being perfectly merged with data from a laser scanner that was on the ground. The result is one single, complete, seamless digital twin, with an average error of just over 3 millimeters. I mean, that is millimeter-level accuracy for an entire construction site. It's incredible.
So, if you think that's cool, what's next? This technology is already amazing, but when you start to combine it with artificial intelligence, that's when you get a real glimpse into the future, the truly autonomous job site.
You see, AI is turning these drones from just being data collectors into truly intelligent observers. They can now analyze their own video feeds to spot tiny concrete cracks a human eye would totally miss. They can automatically monitor the site for safety violations, like checking if everyone's wearing a hard hat. And with on-device AI, they can even make important decisions in real time right there on the drone without needing to connect to the cloud. And the ultimate expression of all this is something called the drone-in-a-box system. Just picture a robotic hangar sitting on the construction site. The drone lives inside it, it charges itself, and then, on a set schedule, it flies a mission, gathers all the latest data, comes back to the box, uploads its findings, and gets ready for the next flight. All of this 24/7 with zero human intervention.
So with all this automation, what does it mean for people's jobs? Well, this roadmap kind of lays out the new career path. Yeah, it starts with being a drone operator, but that's just step one. The real value, the real career, is in becoming a data analyst who can turn all this information into insights, and ultimately, a manager who can use that digital twin to make smarter, faster decisions for the whole project. The future isn't about flying, it's about mastering the data.
So, if there's one thing to take away from all this, it's this. The buildings, the bridges, the cities of tomorrow, they're not just being built with concrete and steel anymore. The next city isn't being built on land. It's being built in data first.